All right, adding and subtracting functions. So way totally different than what we were doing in the last unit with systems and linear systems and graphing and all that stuff. Not a whole lot of graphing, really. Not really a whole lot of word problems. There are some shapes, so we'll get to some shapes, but like, for the most part, it's really just some general algebra. So here we have, let me kind of talk you through what this first problem is. We have f of x equals 3x plus 5, and we have g of x equals 2x minus 5. So f of x and g of x, these aren't like any kind of like, this is not like multiplying or anything. It's not like f times x or g times x. It just means a function of x, and they're essentially just the same as y equals. So don't let that bother you. Don't let the notation bother you. It's just essentially, this is just the name for the function 3x plus 5, and g of x is the name for the function 2x minus 5. We have to give them different letters, like we'll call this one f and we'll call this one g, because we have to distinguish the difference between f and g later on. So we have that. So when it says a, f of x plus g of x, it's saying your f function, which is 3x plus 5, needs to be added with your g function, which is 2x minus 5. So 3x plus 5 is the f of x one, g of x is 2x minus 5. So that's what we're just adding together. The 3x plus 5 is the f of x function, the gx is 2x minus 5. Now when we add them, all we're doing is identifying terms that are alike, terms that go together, combining like terms. So when I look at 3x plus 5 and I look at 2x minus 5, I look at the x terms and I go, okay, well, those match, right? 3x, 2x, they're like terms, they go together, and we're adding them. So we have 3x plus 2x. So if there's 3 x's and then you add 2 x's to it, and that becomes 5x, right? Just simply because 3 plus 2 is 5. And then we have other like terms that we can combine as well. We have 5 plus negative 5. Now in this case, 5 plus a negative number, 5 minus 5, essentially, this is 0, right? That becomes 0. So really, ultimately, at the end, our answer is just 5x, because 5x plus 0 is the same thing as 5x. So what if we subtract it, though, right? If we're subtracting it, we'll have f of x is 3x plus 5, and we're subtracting g of x, which is 2x minus 5. Now, in this case, you have to keep in mind that what we're doing is we're subtracting both of these terms, right? Subtracting 2x and we're subtracting negative 5. So in a sense, you can think, okay, well, I've got my x terms, right? I know which ones are going to be combined. I know that 3x combines with 2x, but it's subtraction, right? 3x minus 2x would be 1, because 3 minus 2 would be 1. So 1x. And then you would also think, okay, I've got like terms. I've got, I've got 5 and my negative 5. But remember, you're subtracting, right? It's 5 minus a negative 5. And when you have minus a negative 5, it's really plus. So it's really like 5 plus 5, which becomes 10. Our answer here is 10, or x plus 10. But let me show you a different approach that I would use to sort of avoid future mistakes, because it's very easy to make mistakes. So when you're subtracting, remember you're subtracting both these terms. So what I do before I combine anything is I distribute this minus sign to both terms. I go ahead and subtract them at the beginning. So I'm subtracting 2x and I'm subtracting a negative 5. So really think of it like distributing that negative in there. You distribute the negative, and that becomes a minus 2x, and the negative with the negative 5 makes a positive 5. So it's really like I'm subtracting 2x, but adding 5, right? So negative 2x plus 5. It's just distributing the negative. This avoids a lot of problems and a lot of mistakes people make in these problems, because sometimes they'll just see 5 and negative 5 and think it'll be 0, and they'll forget that they're supposed to be subtracting that. So distributing the negative is just a good bit of advice. So now you can combine everything without really having to think twice. 3x. Right, we're going to combine, let me get my colors here. 3x combines with 2x, and we're subtracting that. 3 minus 2 is 1x, as we mentioned. And then our 5s combine. And now, again, I don't have to think twice about this. It's positive 5, it's positive 5, and when I combine that makes 10. Right? I don't have to think about subtracting a negative anymore, because I distributed the negative already, and I made it what it was supposed to be, so I didn't have to do anything. Once I've distributed the negative, everything is a lot more straightforward. So let's flip-flop this and do it the other way around. So we'll have g of x first, which is 2x minus 5, subtracting f of x, which is 3x plus 5. Same idea, the same thing we're going to do to start with is I'm subtracting both of these terms, so I'm going to distribute that minus sign to kind of, again, avoid any mistakes later on. So it'll become a minus 3x and minus 5 when you distribute that negative. So this makes things easier to combine. So we identify our like terms, and we just throw them together. 2x minus 3x, that's 2 minus 3, that's negative 1 or negative 1x, or negative x, essentially, right? And then we have our constants. We have negative 5 and minus 5. So negative 5 minus 5 makes negative 10. So our answer there is negative x minus 10. Let's look at number 2. So number 2, we have f of x plus g of x. We have f of x 2x squared plus 2x minus 4. That is f of x, and we're adding g of x, which is x squared plus 3x plus 7. So we're adding, just like the last problem. It looks more complicated because there's more terms, but it's the same idea where you identify which terms are alike, which terms go together, and then combine them. So in this case, we'll combine the x squared. So we have an x squared term here and an x squared term here. So we can combine both of those x squared terms. So we have 2x squared plus 1x squared, and so adding them up, 2 and 1 makes 3x squared. And we continue to find numbers that go together, like terms. So 2x and 3x, those are terms that go together, and we're adding again. So 2x plus 3x is just 5x. And then lastly, we have our constants, negative 4 added to 7, right? Negative 4 plus 7 is positive 3, so it's going to be plus 3 as a result. And that's our final answer. Keep in mind that some people might think this, but you can't do it. You cannot combine these x terms here. 3x squared plus 5x. They both have x in it. That's true. That's good, but doesn't make them like terms. To be like terms, they have to have the same variable, like x, but also have the same exponent. So, you have x to the second power, and then this one is just x to the first power. So they're not the same as far as that goes. So to be like terms, it has to have the same variable and the same exponent. So that's why we can combine 2x squared with 1x squared, because they're both x to the second power. But you can't combine it if they don't have the same exponent as well. So now we'll do b, we'll subtract them. So f of x, we have 2x squared plus 2x minus 4. That's f of x again. Remember, it's right up here. And then we're subtracting g of x. So minus g of x, which is x squared plus 3x plus 7. All right, so just like before, because I'm subtracting, I recognize that I got that minus sign. What I like to do, because it helps me avoid any mistakes, is go ahead and distribute this minus sign throughout all parts of it, because we are subtracting all 3 of those terms. So that'll be minus x squared, a minus 3x, and a minus 7. That'll help me out later when I need to combine my like terms. So let's find terms that we can combine. Again, I've got my x squareds. I can combine those. They're both x to the second power. I've got 2 minus 1. And so 2x squared minus 1x squared is just 1x squared. I've got my x terms, 2x minus 3x, so 2 minus 3. 2 minus 3 is negative 1, so it's negative 1x. And then our constants, we have negative 4 minus 7. So if I take away 4 and I take away 7, then I'm taking away 11, so it's minus 11. And there's our answer, x squared minus x minus 11. Let's do C, where we flip it over. We do the reverse. We do the opposite. We do g of x minus f of x. So g of x was x squared plus 3x plus 7. And we're going to subtract f of x, which is 2x squared plus 2x minus 4. So because it's subtraction again, I'm going to distribute that minus sign so I don't make any mistakes later on. So subtracting 2x squared would be minus 2x squared. Subtracting 2x would be minus 2x. Subtracting negative 4 makes it plus 4. So make sure you're careful about that. That's usually one of those places people would make mistakes. But knowing that we've combined those properly, we should be all right. Negative and negative make a positive 4 there. So bring this down, x squared plus 3x plus 7, and now we'll combine our like terms. So again, x squared, let's focus on those, right? X to the second power. I have 1x squared minus 2x squared. 1 minus 2 makes negative 1, so I have negative 1x squared, or negative x squared. Find more like terms, we have the x terms, right? 3x minus 2x. Those are like terms. Those are the same thing. Let's combine them. 3 minus 2 is 1, so it's just 1x, positive 1x, right? And then last but not least, hold on a second. Last but not least, are constants, right? Positive 7, positive 4. Those add up, make positive 11. And if you'll notice, the answer to the one we just got is kind of the opposite of what we had up in part B, right? You had a positive x squared turn to negative x squared, a negative x turned to positive x, and that negative 11 turned into positive 11. That's always going to happen when you just reverse things around like that. It happened up here as well, right? You had a positive x, positive 10, and then it became a negative x and negative 10. So you're going to notice that when you just flip them over. All right, now number 3 looks more complicated, but again, follows the same general principle where we just combine terms that go together. So let's write this down. F of x plus g of x. F of x is 2x squared plus 5xy plus 3y squared. And then we're adding g of x to it. G of x is 8x squared minus 7y squared. So let's identify terms that go together. You know, the 2x squared, 8x squared, those like terms, those can go together. 2 plus 8 makes 10, so that makes it 10x squared. Now, moving our way down, we're looking at the 5xy. Now, you'll notice there is no other xy term, right? 5xy is the only term that has xy in it. So it has nothing to add or subtract, so it'll stay the same. So it'll just remain as 5xy. And then we do have our y squareds, though. 3y squared minus 7y squared. Those are the same. Those can go together. And 3 minus 7 makes negative 4, so it's going to be negative 4y squared. All right, but now let's subtract, right? Let's do the same thing, but let's subtract. So we'll have 2x squared plus 5xy plus 3y squared. And we're going to subtract, so minus g of x, which is 8x squared minus 7y squared. So again, to avoid any mistakes, I'm going to distribute this minus sign first. So it's minus 8x squared and plus 7y squared. And then I'll be able to combine my like terms really without any issues. So when I combine like terms, I'll look at my x squareds. I've got 2x squared minus 8x squared. Those can go together. Those are both x squared terms. 2 minus 8 is negative 6, so it's negative 6x squared. Then I've got my xy term again, right? My 5xy, there's nothing being added to it. There's nothing being subtracted to it. There is no other xy term for it to combine with. So it remains just 5xy. And then lastly, we have our y to the thirds. So you'll see 3y, or y to the seconds, 3y to the second plus 7y to the second. 3 plus 7 makes 10y to the second. So plus 10y squared. Now, you'll probably already know what the answer to this is if you compare how 1 and 2 worked out. But we're going to work it out from scratch, and we'll see what we get as a result. So g of x is 8x squared minus 7y squared. And we're subtracting f of x, which is 2x squared plus 5xy plus 3y squared. So again, avoiding any issues, I'm going to distribute this negative. So minus 2x squared minus 5xy and minus 3y squared. So now I can combine my like terms without really any issues. So 8x squared minus 2x squared, 8 minus 2 makes 6, so it's 6x squared. And you'll notice that's the opposite of what we got in B, where we had negative 6x squared. Now we'll combine, let's look at, just for sake of it, we'll look at the xy next. So negative 5xy. Again, there is no other xy term, so it's going to be staying the same. So it's minus 5xy. You'll notice, again, that's the opposite of positive 5xy that we had in part B. And then lastly, our y squared. So negative 7y squared, negative 3y squared. That makes negative 10y squared. Again, opposite of the positive 10y squared we had in part C. or part B. All right. Now, finding the perimeter. Now we're talking about shapes. So finding the perimeter. Perimeter is just adding up all the edges together, all 3 sides or 4 sides, however many is in your shape. We have a triangle here. So our perimeter is just going to be the length of all 3 sides added together, right? So I know all 3 sides, at least not as a number, but as an expression. I know that we have 4x minus 8. And if we're finding perimeter, we're going to add the other side. So we're going to add the 3 minus 2x. We're going to add that to it. And then, because it's the perimeter, it's got to be all the sides, right? We're going to add that last side. So we're going to add 11 plus y. So those are all 3 sides being added together. That's all we do to find the perimeter. Now, our answer is not going to be a number because none of these sides were a number, right? Everything was an expression. Our answer is going to be written as an expression as well. So don't let that bother you. It's just going to be you combining your like terms like last time, right? So let's look at the x terms. We have 4x and 2x minus 2x. 4x minus 2x is 2x. So that takes care of those. Let's look at our constants. We have negative 8 plus 3 plus 11. So negative 8 plus 3 is negative 5, and negative 5 plus 11 is 6. So that'll be plus 6 overall. All 3 of those numbers combine to make plus 6. And then lastly, we have our y. That's the only y that's there. It's just a positive y being added, so it's plus y. That is our answer for the perimeter. It's just adding up those sides together. All right, we'll look at the next one. It looks a lot longer. Now, I know what I have to do. I know I have to add up all 4 sides, right? And now, instead of writing, this plus this plus this plus this, because that's going to be a lot. I mean, it can. But just so, I know I'm adding all together. So I'm just going to add my like terms right off the bat. So, I know if I'm going to add all the sides, I'm going to add the b's together, the a's together, the numbers together. So let's just focus on the b's first, right? If I add the b's, I've got 3b plus another 3b. Those are the only b's. And I'm adding them up. So 3b plus 3b is going to make 6b, right? So that takes care of those. Now let's combine our a's. So our a's, I have negative 4a plus 2a minus 4a plus 2a. So when I add those up, negative 4 plus 2, negative 4 plus 2, that's going to be negative 4 altogether. Right? Negative 4 plus 2 is negative 2. Minus 4 is negative 6. Plus 2 again would be negative 4. So it would be a negative or minus 4a. And then you've got your constants. You got 5 plus 6 plus 5 plus 6. Adding those all up, you get 22. So without having to write them all down again, I just looked for the like terms and I went ahead and combined all those like terms. And I get my final result, which is nice. All right, I'm going to end this video here because that's where we stopped in class on Monday. So I'll continue more of these notes in a separate video. See you guys.